Okay, so today we are talking about two-dimensional figures. Two-dimensional figures fall into two categories pretty much. You have polygons and then you have shapes that are not polygons, which pretty much comes down to circles and ovals and other random shapes that people decide to draw. So polygons are they're shapes that are composed entirely of straight lines and they connect at vertices. So a polygon, an example of a polygon would be like this rectangle here. So this lovely, lovely yellow rectangle. So it has straight sides that connect at these points that I'm drawing in black here. So those black points would be the vertexes of a polygon. And polygons can be either concave or convex. This rectangle would be convex because when we draw lines between, oh, that was a nice line there. So we can draw lines between all of the vertices, I use those both. Vertices is correct, but I don't know, it doesn't always roll off the tongue for me. When we connect all of those, they're all contained within the figure. So if we had something that was concave, it might look like that. And then when we drew our lines in, we can see this yellow line falls outside of the shape, which of the polygon, which makes it concave because that line falls outside of our shape's borders. So that's a brief overview of concave, convex. An n-gons are polygons with a lot of sides. So you could have like a 40-gon or a 50-gon, and that would be a shape with 40 sides would be a 40-gon. A shape with 50 sides would be a 40-gon. Something with 722 sides would be a 722-gon, so on and so forth. Mathematicians are not great at naming things, so once we run out of prefixes, it just becomes an n whatever. So n-gon would be a polygon with n number of sides. Equilateral polygons, equilateral means that all the sides are the same length. So all the sides, lateral sides, are all equal. So shapes with all the same sides. So think like a square where all the sides are the same. Just like equilateral, equiangular means all the angles are the same. So an example of this would be the square or this rectangle even. All these are 90-degree angles, which means they're equiangular. Now, a regular polygon is equiangular and equilateral. So a square is a perfect example for a regular polygon. It has all the same side lengths and all the same angle measures. So regular just means it's perfect. It has all the same sides, all the same angles. They're delightful. They're perfect. We love them. The perimeter is the distance around the outside. So for this rectangle, we could have side lengths of 2, 2, 1, and 1. So for the perimeter, we would add those all up and we would get 6 units. So it's the distance around the outside of a polygon. Now the circumference is the distance outside of a circle. Ooh, that's not what we wanted to do. We wanted to make this smaller. Drag that over here. So that would be like the green area on this circle would be the circumference. Then the area is like the distance in, or the space inside of something. So like if I shaded this whole rectangle yellow here, the yellow part on the inside, that's our area. And how we find our area is we do our length times width for a rectangle. So we would end up with an area of like 2 units squared. Now that squared is very important because that shows us that it's square units instead of, because 2 units squared is a lot bigger than just 2 units. And so it's important to have that square in there. Okay. So a polygon is a closed figure formed by a finite number of coplanar segments called sides, and such that blah, 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 blah. It's a shape made of straight lines, and they all connect. It's a closed figure. So something like this is not a polygon because we have this side that doesn't connect to anything. So it has to be a closed figure, big picture, and it can't have rounded sides. So something like this, imagine all my sides are perfectly square, and then a rounded top, like the key on a basketball court, that would not be a polygon. There's our key, 3-point line. We got our hoop. Perfect. Lovely. So name the polygon by its number of sides and classify it as convex or concave and regular or irregular. So right off the bat, it's a quadrilateral. There's 4 sides, it's quadrilateral. If we need to go over the names of shapes, we can do that. I had to do that last year. It broke my heart a little bit, but it's fine. We can do it. Let me know if you want to go over the names of shapes. So 4 sides, quadrilateral. Since when we connect all our vertices here, I'm going to do that in yellow. Boom. Boom. And then the rest are just the sides. It's all self-contained, so it is convex. So it's convex right off the bat. Regular or irregular, all the angles are different, all the sides are different, so it is irregular. So it's going to be a irregular, convex quadrilateral. Lovely. So now this shape is 9-sided, so it's a nonagon. And this one is actually concave because if we connect these 2 points here, you see how this yellow line falls outside of the original polygon? That makes it concave because it's closed in on itself. So it's concave. Once again, different side lengths, different angle measures. So it's irregular. So we would say it's an irregular, concave nonagon. Delightful. So, name the polygon by its number of sides and classify it as concave or convex. Right off the bat, this is a triangle. Wow, I know so many shapes. So, it's a triangle. It's convex because none of the sides, when we connect all the individual vertices, it all lies within the figure. So it's convex. And then if we look, all the side lengths are the same, and they notate that. And all the angles are the same. They notate that with those little hash marks. So it's a regular convex triangle. So letter D. Name the polygon, classify it, blah, blah, blah. It's quadrilateral, it has 4 sides. All the side lengths are the same, but the angles are not the same. We can see we have some obtuse and some acute angles here. So it is going to be irregular. It is convex, and it's quadrilateral. So an irregular, convex quadrilateral. So it must be A. Now, this is the formula page. Pause the video, write all these down. Super important that you have these formulas. You're going to need them on tests and quizzes. You're going to use these for a long time. Make sure you write these down and know these. We're not going to ask you to memorize them for this class, but make sure you write them down. As you use them more, you're just going to end up memorizing them. So find the perimeter and area of the figure. So our perimeter, the distance outside of this, I'm just going to write 2.3 and 4.6 because I know the big sides on a rectangle and the little sides on a rectangle are equal. So let's add all these up. 2.3 plus 2.3 plus 4.6 plus 4.6 is going to be 12, 13.2. My brain stopped working. 13.8, I believe. So it should be 13.8 8 centimeters, which we can double check that real quick, because 2.3, 2.3, 4.6, 4.6. If we add all those up, we get 8, carry the 1, which makes this 13, carry the decimal down. Perfect, lovely. And then if we do, for our area, we have to do 2.3, our length, times our width. So 2.3 times 4.6 ends up equaling 10.58 centimeters squared. Make sure you include that squared. It's very, very important. That's the same deal. So circumference and area of this figure. So an important thing to note is the diameter is just twice the radius. So my diameter here is going to be 2 times 4, which is 8. So my circumference equals 8 times pi. So I'm just going to write it as 8 pi, and I'm going to leave it like that because we get into decimal nonsense when we start That's interesting. So, sorry, someone just rode by playing music. But anyway, I forgot where I was. That's lovely. So area, yes, area of this shape. So our area equals pi times radius squared. And our radius is 4 inches. So I'm going to write A equals pi times r, oh, no, it's 4, so times 4 squared. Excuse my handwriting. So 4 squared is 16, so my area is going to be 16 pi, and then inches cubed, because we always label, even though I didn't on the first one, but do as I say, not as I do. So that's our area for that. Now, let's look at this one real quick, and then we're going to conclude part 1 of this video. So our side lengths, once again, are 4.3, 8.1. I'm going to copy them over. I like to do that just so I can more visually see it. And if we add these up, 4.3, 4.3, 8.1, 8.1, we end up with 24.8 centimeters. So right off the bat, it's got to be B. That's the only one with a perimeter of 24.8. But we'll go ahead and multiply these out just to make sure. So 8.1 times 4.3 is going to be our area, which, let's punch it in the calculator. It does equal 34.83 then centimeters squared for our area. So that checks out. We're all fine and dandy. We'll do this problem too, and then we'll call it. And then I'll make a separate video for the last 2 problems because they are bears, let me tell you. So find the circumference and area of this figure. So our circumference, as we said, was going to be pi times our diameter, which our diameter is twice our radius. So our diameter is going to be 16 meters. And now they do actually want us to multiply out this times pi. So 16 times pi, where's my pi button, equals 50.26. So our only circumference that could possibly be is C, because if we round it to the 10th, it's 50.3. And then we can double check our area just to make sure. Area equals pi r squared, and our radius is 8. So pi times 8 squared. 8 squared is 64, so 64 pi. 64 times pi equals 201.06. So that checks out. So it's got to be C. All right, and this concludes part 1 of the video. Please go watch part 2, and just know it's going to be rough, but that's all right. We're going to get through it. Have a great